All righty. Good morning. We've got our attendees loading in. Hello to everybody. This is the USHST All Hands webinar, our last one of the 2023. We appreciate everybody's attendance. We've got a great agenda lined up here. I'm going to go to that slide right now. It's packed full of very interesting topics, and we certainly appreciate all of our presenters. We've got a couple of frequent flyers. Pretty much everyone's a frequent flyer now with Lee and Jessica and Hannah. So we certainly appreciate your participation. Just for everybody's knowledge, please use chat in to post questions or ask questions, or the Q&A is another perfect area for that. We'll be posting having some polling questions here that you can answer. Then I'll be posting some links to some various videos and studies that the presenters have for you all to look at. So I encourage you to take a look at that. Just very quickly, you all will get some credits here with Wings credits. I think we've got one Wings credit for basic knowledge with topic 3, a half credit of advanced knowledge for topic 2, and for our maintenance technicians out there, you get 1 hour total. So without further ado, I'm gonna go ahead and turn over to Chris Bauer, one of our co-chairs, and let him have some introductory words.
Thanks, Chris. Pleasure to be here today. Thank you, everyone, for participating in this USHST All Hands meeting today. It speaks volumes of your professionalism to take time out of your busy schedules, and as Chris pointed out, you do get Wings credit for it. A lot of very salient topics in this webinar, so I know it's going to be kind of fast and furious, but I've had my own personal encounters with helicopter wake turbulence, and until you've experienced it, it's something you probably don't want to experience a second time. So that's about all I really wanted to take up your time with, and perhaps introduce Robert Record, my co-chair from the FAA.
And Robert, you on?
Yes, I am, Christopher, and good afternoon, everybody, and thanks for the introduction, Chris. Just like to take a few minutes, just like Chris said, and thank everybody for joining and for your interest in improving safety, particularly in the helicopter community. As Chris said, I'm Rob Record. I'm the division manager for AFS 200, which is the Air Transportation Division within our Office of Safety Standards in the Flight Standards Service. I'm excited to let you know I am a helicopter pilot myself, and I'm excited for the work that we're going to do as a team to help mitigate risks, improve safety, and the overall performance of helicopters within the NAS. So with that, Christopher and Chris, really appreciate the introduction, and excited to be part of the team as the government co-chair.
Thanks, Robert. Thanks, Chris, for both of your all's leadership with the U.S. Helicopter Safety Team. And with that, let's kick it into our first polling question. Ashton, if you could pull that up. All righty. Hopefully everyone can see that. I'll read it out. If the percentage of all U.S. helicopter accidents, both fatal and non-fatal, from the 3 industry segments of instructional training, aerial application, and personal private were combined, what would be the approximate total percentage be so far for calendar year 2023? And Lee's got some percentages there for everybody to take a look at. Let's folks start to answer those questions, or that question, excuse me. Let's see, we've got about 65% participation now. All right, why don't we go ahead and share those results, Ashton? All right, it looks like the majority of the participants said 25%, then followed by 40, 60, and 75. And we'll let Lee answer that question right now as he begins his presentation. So Lee Roscoe from the FAA will be giving a presentation on our rotorcraft accidents. Go ahead, Lee.
All right, thanks, Chris. If you could confirm what you see on the screen now, if I'm in presenter mode or another mode.
I've got you back in your raw slide mode.
All right. Let me give it another shot here then.
No worries. If not, we can go with what we got.
Sure.
That's just you now.
Better or the same?
You got it.
Okay, perfect. Thanks. All right, everybody. Thank you for the introduction, Chris. We will get into the answer to the polling question as we move along here a little bit. But to continue here, getting into it, this is the slide we usually start with. Just an overview of where we're at in terms of the U.S. Helicopter safety team's goal to reduce the 5-year average fatal accident rate in the U.S. to 0.55 per 100,000 flight hours by 2025. So you can see there on the far right side of the chart, we currently are sitting at 0.73 per 100,000 flight hours, and you can see from the amount of time that we have left, we've got just over a year left in the goal measurement period. I thought it would be interesting too. Sometimes, I put these up every quarter as we do these sorts of reviews, and it's hard to remember, hey, where were we at a few months ago? So in this case, I've got 1 year ago we were at 0.78 per 100,000 flight hours compared to where we're at right now at 0.73. And at first glance, especially if you haven't tuned into one of these before, you're like, wow, that doesn't seem like a lot of progress over the course of a year. But honestly, the reason we're using a 5-year average is we shouldn't see very volatile swings from year to year. The whole intent of going to a 5-year average when the steering committee decided to do that was to sort of smooth out and dampen out some of the year-to-year volatility that we saw. As I've talked about before, 3 of the years that are factoring into our current 5-year average, we're at 0.8 per 100,000 flight hours. The last 2 years have been better. 2022 and now 2023, we've got 2 months left in it, but it's been better as well. So as we see more of those years where we see improvements in the rate come in, and some of those ones that are kind of pulling the average up drop off, we should see that continue to decline. This is the same sort of chart, just displayed in a different way. The bar on the far left side of the chart is the baseline rate that we use for 2014 through 2018, and the green bar on the far right side of the chart is what the goal rate is, at 0.5. And those 4 bars that you see in the middle are just different time frames of measurement. The first one being what you saw on the previous slide, the 0.73 per 100,000 flight hours. That's for the 5-year period that we currently have in progress. As you move one over to the 0.71 per 100,000 flight hours, that is for the almost 4 years that we have, that's encompassed in what the USHST's final 5-year measurement period will be, which will be 2020 to 2024. So right now we've got 2020 and most of 2023 factoring in there. For the current calendar year, 2023, we are at 0.61 per 100,000 flight hours. And for the month that just concluded yesterday, we were at 0.39 per 100,000 flight hours. So to give an idea what those look like from a count standpoint, the blue line that you see on the chart is the baseline for 2014 through 2018, and the green line is what we have for 2023. So you can see we talked about January, February, we started great out of the gate, no fatal accidents in either one of those months. March, there were 4, and then we went through a series of months where there was only 0 or 1 fatal accidents until we get to the end of June and into July, August timeframe. Now, worth pointing out here, as you look at January through June, at that point in time, we had only observed 6 fatal accidents for the first 6 months of the year, and we were tracking at a historically low rate for the year of 0.41 per 100,000 flight hours. July and August backtracked us on that quite a bit for fatal accidents for both those months, but September and October have been better, with no fatal accidents during September and only 1 during October. So even though we'd seen these counts result in a rate that went up to 0.7, the recovery in September and October gets our rate down to what you saw on the last slide of 0.61 for the calendar year. Also worth noting, if you look at sort of the the steep parts of the chart versus the shallow parts of the chart. We basically have 3 months that are driving where our count is right now. 3 months account for 12 of the fatal accidents that we've seen this year. So, all right, and now if we transition to just looking at individual year fatal accident rates, and see a little bit of what I was talking about on the opening slide with regard to we have the 3 years here that are factoring into the current 5-year average. That we were really locked into that 0.8 per 100,000 flight hours. The last couple of years, we've been closer to the 0.6, to 0.65 sort of range. So the more that continues, obviously, the more that will drive it down. Same kind of thing on the fatality rate. Of course, this is measuring the number of occupants that have lost lives in the fatal accidents versus the previous chart was for the fatal accidents themselves. So again, some recovery in July or in September and October to get the rate closer to this 1.18 level that we see on here. Right now, it had jumped up from what we saw in July and August in terms of the higher number of fatal accidents and fatalities those months. And then finally, the overall accident rate chart. You can see we're trending at close to what would be the lowest over the last 23, 24-year period at 3.48 per 100,000 flight hours. And this is probably as good a time as any on all these rates that you see for years up through 2021. The hours that are used for these calculations are based on the General Aviation Part 135 Activity Survey. For our for 2022 and 2023, they're based on the FAA's forecast. We should have the 2022 GM Part 135 Activity Survey results that are ready to be publicly available soon. So we'll update that as needed. This also, it's not the season where it's opened yet, but for all those who receive a survey, which should be 100% of registered owners and operators of U.S. helicopters in the U.S., please fill those out because you're seeing how the data is used right now in order to normalize these rates. The next thing I wanted to do was transition to just showing some of our industry sector trends, and this feeds into the polling question that was out there. You can see the on the far left side of the chart, the industries that account for about 60% of our overall accidents, both fatal and non-fatal this year, are instructional training, aerial application, and personal private. So the blue bars give you what the count of each one of those were. The orange line that you see there gives you an idea of the cumulative percentage. If you add the 24% from instructional training, another 21% for aerial application gets you 45%, at another 14% for personal private gets you to 59%. So 60% of our total accidents for helicopters in the US this year have come from one of those 3 industry categories. And you can see there's a drop off from there for the other industry sectors. One thing to point out, for those who've followed the numbers for years, personal private is often leading this chart, if not leading this chart by a lot. And this particular year, for whatever reason, cumulative effects of a lot of different outreach. I'm not sure on all the reasons for it, but you can see there's quite a bit of distance and daylight between personal private and the other 2 categories. So, I hope that continues because again, that's been one of the struggle areas for us in terms of fatal accident reduction and overall accident reduction for the year. So all of you out there that are participating in outreach to personal private operators, thank you. Your work is doing some good. This chart, same kind of style, but just focused on the fatal accidents versus the overall accidents. I can see aerial application, which is our Part 135 ag operators, are leading in this one with 4 fatal accidents for the year. Those were all in July and August. 3 of the 4 of them were in July, and 3 of the 4 of them also had wire strike involvement. And the investigations are still in process. So not saying that wire strike necessarily was causal. It may or may not have been, but saying that definitively on the preliminary reports that have been put out that wires were involved in some way. I'll point out personal private here again, even though it's second in the fatal accident category. The the personal private accidents were between March and May. And I only point that out because there's been so many months that have passed since the last one occurred. And again, that's probably one of the reasons that overall accidents are lower and our fatal accidents aren't higher, because usually personal private, that's another one where it'll lead our fatal accident percentages for the year, or when we aggregate the data into multiple years, it's often accounting for 20-25% of our fatal accidents. So that's a wrap up on the industry sector analysis. You all know that we have the Rotorcraft accident dashboard that's available 24/7 out there, updated each week. This QR code will get you there. So I'd like to promote that every chance that I get, because our folks do a great job of making sure the accidents are input as soon as we know about them, so that can be updated. So that should wrap it up for my section, Chris. So back to you.
Awesome. Hey, thanks so much. I did post the link to the dashboard in the chat. We did have one question in regards to the presentation being available for download, and assume you'll share that, post that, upload that into the USHST website for access. But certainly, folks can get those live stats going to the dashboard. And thanks for your team for having that. There was another question.
Happy to share the presentation.
Yeah, thank you. Another question in the chat. Are these numbers civil only, or do they account for public aircraft operations as well? So assuming municipalities, state, and county operations.
Yeah, public use are in there as well. So it's 91, 135, 133, 137, and public use are incorporated in the numbers.
Perfect. Great. Thank you, Lee. Let's see, we got one more. Nope, thank you. All right, I think that's all for questions. And there'll be some time at the very end for additional questions if people want to follow up as well. So if we could, thank you. Thanks again, Lee.
Yeah, you're welcome.
Certainly for everybody, those top three categories that you highlighted, tend to be the same ones from year to year. So again, what USHST is trying to help are those personal private and training and ag folks, and a lot of good work going on. We just need to get people more aware and engaged to help themselves in those industry segments. One last minute question: Oshkosh fatalities included? I think those numbers were in there.
Yes, that is correct.
Okay, greatly. Thanks again. Appreciate it as always.
Yep, you're welcome.
All righty. Let's go to our next polling question. And have you ever made a poor choice because you did not have adequate resources or all the necessary information to make that decision? We'll let folks start answering that. While folks are answering, I'm going to share my screen as well. Hopefully y'all can see that. And we've got about 72% participation. So why don't we go ahead and in the poll and share those results. So significantly, everyone has answered yes. So and kind of expected that, right? We've all made mistakes as humans. You all know that we tend to do those, whether that's in aviation or in our personal lives. And so one of the things I wanted to highlight, and I apologize, Steve Motorano was not available today, some travel changes for him. So I'm filling in on this next topic where we're talking about one of the new helicopter safety enhancements. And for folks that aren't aware of what the, let's see, let me try to end this window here, aren't aware, back in 2017, a group from the U.S. helicopter safety team, or at that time it may have been part of the International Helicopter Safety Team, which is now VAST, Vertical Aviation Safety Team. But nonetheless, they did a deep dive into 117, or excuse me, into I forget the total number of accidents, but came out with a list of 117 intervention strategies that perhaps could have helped mitigate or prevented the accidents that were analyzed. And because of kind kind of the bandwidth at the time, unfortunately, only 16 helicopter safety enhancements were chosen based on kind of a hierarchy or level of importance or priority to work on. And so these next 5 are part of that original 117 that just didn't happen to make the cut, so to speak, using a Mendoza line kind of analysis. But we now have these new 5 that you can see on the screen, and I'm going to quickly just focus on that first one, which relates to decision making. And so you can see the name there: professional pre-flight planning and go no-go aeronautical decision making is the title. And again, as we know, we just answered a question there that kind of reflects that, hey, we probably could do a better job at making choices to help create better outcomes, right? And so the team has put this out there. This kind of the group behind this helicopter safety enhancement is the working group. HAI's safety working group team members have volunteered to work on this, and we began as part of that working group, as well as Jessica and others on the line. We began by defining some milestones, and you can see those milestones right now, where we looked at kind of information related to defining what the problem is, conducting a gap analysis to determine current resources that might help or are not available, then identify some solutions that we could put forward to the industry to help with improving pre-flight planning and aeronautical decision making, and then promote those solutions, and then of course using the safety management mindset of continuous improvement, and then promoting through an outreach program. And so right now we're on milestone 3, and some of the ideas around milestone 3 are enhancing training out there for either new pilots or on ongoing continuing basis for current pilots and even for maintenance technicians. Some social media campaigns, the inclusion of videos and so forth, and then coordination among some of the audit organizations or entities that are out there to help, again, promote the idea around decision making and choices. One other area that we're working on is creating a definition for what is conservative decision making as well. While those milestones are in progress, in parallel, we typically we wait till a milestone is complete to push things out, but we've already kind of begun the process of promoting better decision making. One of those was the use of the FAA weather camera program. Hopefully some of you have used that, but we posted a small article in HAI's Spotlight on Safety video, and I'll put the link in the chat here shortly for y'all to take a look at. Also, the U.S. Helicopter Safety Team hosted a summit back in April, where we kind of dove in pretty deeply into the aviation weather camera program. Cole Pope, who manages that for the FAA, was part of that, and we had some speakers, pilots from Air Methods that joined in, that kind of described on how they utilize not only the FAA weather camera program or the en route decision point mindset, but also, depending on what state you live in, there's a lot of Department of Transportation cameras that clearly are focused on the roads and highways in the state, but can provide a means to show what the weather is at a particular point that maybe is along your route. And so that was really helpful. Again, this is an ongoing process. We still have a lot of work to do, but that's kind of where we are. We recognize how important decision making is in what we do on a daily basis, whether we're fixing the aircraft or flying them, or even managing, or from an administrative standpoint. We as an industry just need to make better choices and produce those positive outcomes that help reduce the accidents, whether they're fatal or non-fatal, in our industry. So that's about all I've got. Let's take a look real quick on any questions that have come in. Let's see. We've got one that goes back to Lee's question. Let's see if there's anything else from me. Improving helicopter simulators considered as an improvement, absolutely. And that goes back to our training, right? How we can provide and complete more effective training, whether that's ab initio training, real scenario-based training, things like that to help us improve. And then, when we look again at those three sectors, personal, private, that's an area that we really want to focus on because that tends to be the highest, as well as the agriculture, aero application industry as well. But hopefully you all in your personal, private, owner operators are really looking at training as a viable and important mechanism, whether you can get to a simulator or some type of flight training device, in the aircraft type of training, inadvertent IMC, unintended IMC training, certainly a good methodology for you to practice, considering a lot of the accidents that we've experienced in the helicopter industry relate to those encounters with IMC conditions. So anyways, hopefully that was helpful for you. We'll continue to update the industry as we progress through this helicopter safety enhancement as well as the others. Let's see. In the accident analysis, were there any actionable root causes identified? And I think it goes back to Lee's presentation. Absolutely. And that's where these helicopter safety enhancements came from, to help identify what mitigation strategies or interventions that we talked about could be implemented. I don't see any other questions. I'm going to stop sharing my slides. And why don't we go to our next polling question? And if any other questions come in, we'll keep track of those and try to get back some answers back to everybody.
Hey, Chris, there was one about the HEMS industry and the accident rates. I don't know if Lee or someone wants to address that question. It's in the Q&A.
Okay.
Yeah, I can answer that one. I'll type a response.
Thanks,
Great.
Lee. Appreciate that, Jessica. And so we got our polling question. Choose the answer that best fits you. And this relates to our next presentation from Jessica about mountain flying awareness. And those results are coming in. We got about 47% participation so far. We'll get some more folks in there. %. Keep coming, guys, folks. All right, we're about 66. So I'm gonna go ahead and share those results. And I don't know, Jessica, I don't know if you can see those or not.
Yeah,
Okay,
I can.
great. Yeah, it looks like the highest percentage, not by much, but I have flown in mountain environments a lot, either past or present, followed by I have flown in mountains some as needed for my job or to get from here to there and so on. So without further ado, I'll turn it over to you, Jessica, and maybe you can touch on these answers in your presentation.
Yeah, absolutely. So thanks, everybody. Really appreciate your time. My name is Jessica, and I am a pilot based out of Colorado Springs, Colorado. I split my time between utility flying and flight instruction. And this presentation is in collaboration with Colorado Highland Helicopters based in Durango. And they provided part of a presentation that I then adapted specifically for this webinar. So thanks to Colorado Highland for the information that they provided and some of the images as well, you'll see from them. Quick disclaimer. So we'll discuss some considerations for helicopter operations in mountains. Obviously, mountain flying carries with it some inherent risk. And this is by no means a replacement for proper hands-on training from a qualified instructor in qualified environments. And also our focus here is going to be in high altitude and mountain operations, getting you through the terrain. We aren't going to be covering approaches to landings, techniques to get to a landing site, or maneuvering within mountain terrain. So our focus is getting through the terrain, not necessarily spending time within the terrain. And some considerations, this is the structure of the presentation, starting with helicopter performance, then moving towards some environmental considerations like wind, some crew and physiological considerations, then navigation, and finally backcountry preparation, what you should consider having on board when you're traveling in backcountry remote environments and specifically through the mountains. starting with helicopter performance. So a good rule of thumb is to plan to have out of ground effect hover performance, regardless of what your plan is and your available landing sites. Because landing off airports often require more power than your in-ground effect charts might say. And even if you're going through the mountains, you don't intend to land. Of course, we want to plan for the worst and expect the best. So we need to plan to land, even if that's not your actual intention, and therefore have the proper hover performance to be able to handle that type of forced landing situation. And don't always assume that bigger is better. So having our machine be up to the task is a critical component of this, not only our person, but our environment and our machine. And often a larger helicopter isn't always the better choice for mountain environments. It doesn't always equate to better performance or more power. And that's why you'll see a lot of common helicopter models in mountainous terrain for search and rescue or things of that nature are smaller single engine helicopters. The H-125 is a great example. And then the MD-500 series is another good example. Good bang for your buck in terms of mountain and high performance. And when you're doing performance planning, one approach is to consider a temperature and altitude envelope within your performance plan, rather than a hover ceiling that's fixed with weight and temperature. Especially if you're thinking a multi-hour trip through mountainous environments, those conditions are going to change. And so here's an example of that envelope I was talking about. And in particular, bring your attention to the right side of that chart where there's a type takeoff mass, TOM, that's changing throughout time as you burn fuel, and then also accounting for changing temperatures and altitudes. Maneuvering in mountain terrain often requires several different altitudes, and it's good to know what your overall envelope, your performance parameters are in a bigger picture, as well as your specifics for your limitations, like a hover ceiling or manifold pressure setting or torque for that particular day. So having both and using this envelope approach is one way to do your helicopter performance planning for dynamic environments like the mountains. Moving on towards environmental considerations, wind direction and speed are two of the most critical components, of course, for any helicopter operation, but especially in the mountains. Having that awareness of wind direction and speed is absolutely critical. And not only evaluating what's happening prevailing winds, so doing your planning for the day, but also what can happen more locally. And what I mean by local is that particular valley or that particular ridge, and how that relates to your regional or your prevailing winds for the day that are constantly going to be shifting, especially the local winds. As the terrain starts to rise, the wind is going to follow that, and that's called the windward side of the terrain. As the ground starts to fall, going over a mountain or over a ridge, the wind's going to fall with it. That's the leeward or leeward, depending on where you're from, side of the mountains. And the more rugged the terrain, so the steeper the terrain, the more turbulent the wind can be. So air that's passing through a narrow valley or in a saddle is going to increase very rapidly in speed. And that's due to the Venturi effect, simple physics. Just like lift is produced, it's the same type of concept. And that wind will funnel through a tighter area. And we need to be aware of how that's going to affect our potential to fly in those areas. Simple diagram about windward and leeward sides of the mountains. In particular, that right side diagram gives you a better sense of how turbulence can be generated on the leeward side of the mountain, and that can significantly affect our ability to operate in that area. So windward slope is going to have a lot less turbulence and more favorable updrafting conditions. And in that sense, the helicopter can have positive power, better lift, need less power to operate on that side of the terrain. Whereas on the other side, the leeward side, it's much more hazardous, more turbulence, and the wind is more likely to change throughout the time in that terrain in speed and direction across the board. And one of the most challenging aspects is to plan for those downdrafts on the leeward sides, which can be strong enough to push the helicopter down into terrain and cause it to impact terrain. And that definition, that line between the windward and the leeward side, is called the demarcation line. And that's where those two airflows meet. and can also include a lot more turbulence in that area. The wind is kind of falling off like a waterfall, and water is a great analogy for how wind can behave in the mountains. It's falling off that terrain like it would going over a boulder in a stream. And what happens on the other side? If you're a kayaker, you might understand that as a hole or an eddy where the water becomes more turbulent. Same thing happens with air going up and over terrain. And so if possible, if you can estimate where that demarcation line is and make an effort to stay above it, so you're not caught in that turbulent terrain, turbulent wind that's beneath the demarcation line. And that line will steepen with increased velocity. So if the wind's going faster, you'll see that line start to steepen, and it'll steepen with increased angle of terrain. So as the mountains get, the angles get steeper, that demarcation line will also steepen. If you're traveling through, say, a valley, then understanding what side, windward or leeward side, is really important so that you can follow, hopefully, the updrafting side or the windward side, and you can contour crawl along that valley and taking advantage of those updrafts rather than fighting the turbulence and downdrafts on the opposite side, the leeward side. Lastly, for environmental, how do we handle crossing a ridge or crossing a saddle? And typically that's with a 20 to 45 degree angle and a vertical distance of about 1,000 AGL. So that angle will allow you to have an escape route, to have a way to bail if something were to happen or you encounter a downdraft that you didn't expect. And again, staying about 1,000 feet above the terrain will also give you some escape options to mitigate any issues that you might come up with. So about 1,000 feet, 20 to 45 degree angle. Weather conditions can change rapidly in the mountains. And if you are in a mountain valley or traveling through a mountain valley, which is often the lowest point and makes sense for performance, a mountain valley can very easily lead to entrapment. So before the opportunity for fog or clouds roll into that valley and keep you in there and trap you in there, have a few different options for getting out, for your egress. Where are you going to exit this valley if something were to change about your conditions? Don't ever assume that conditions in one area are going to be the same to the next valley over. So, hey, looks nice, VFR conditions, and then you cross this low point, cross the saddle, and all of a sudden it's a very different environment over on the other side. And along those same lines as before, always having different options when you're in a valley, take that same mindset when crossing from one area to another. Always understand where you are, maintaining situational awareness, and having a few different escape options to get out from your current position. Moving more towards some physiological stuff. So spatial disorientation is a huge concern when you're operating in mountain environments and in valleys. It's much easier to get disoriented. Your distance references are changing. We no longer have a distinct horizon. And so take those challenges and add anything else that you might be dealing with: tough decision-making, turbulence or wind, low visibility, precipitation on the windshield, whether it be snow or rain, can all increase that risk of spatial disorientation. And that can be a pretty serious situation pretty quickly in the mountain environments. And hypoxia, another concern. Not all mountain flying is considered high altitude. The Alaskan mountains are a great example. However, if you aren't accustomed to operating at any altitude, say you're from sea level, then hypoxia is going to be a major concern, even at what we would consider lower altitude mountains, say 3,000 or 4,000 feet. So the higher you travel and the longer you stay there, your exposure has a cumulative negative effect on your decision-making, your cognition, your memory and motor skills. And a few studies have shown some pretty severe impairment with hypoxia at about 9,000 feet and higher. So if you're in that higher altitude terrain, here in Colorado, our field elevation for Colorado Springs Airport is over 6,000 feet. And that puts you in that 9,000 range on your everyday instrument approach. And that hypoxia becomes a much bigger concern in unpressurized cabins in particular. So especially above 10,000, effects on eyesight become more critical, in addition to some of the other concerns like decision-making, motor skills, and memory loss. Some of the other issues that you might encounter, dehydration can be one of those conditions that can compound with something else going on. So hypoxia, or the second bullet there, acute mountain sickness or AMS, especially if you aren't accustomed to being in a high altitude environment, then those two things can sometimes mask other situations that are going on, because the symptoms are often similar. You might have a headache, you might be a little slow to react, you might have a little bit of cognition stuff going on, and they're all similar enough where it might be hard to distinguish what is actually happening physiologically. So being aware of all of those considerations, spatial disorientation, dehydration, acute mountain sickness, hypoxia, and then knowing yourself well enough to help distinguish between them and then treat the appropriate condition, which typically looks like descending, getting out of the mountain environment if you can. If that's not possible, then treating those as they come. Visual illusions related to, but distinct from, spatial disorientation. Even though something like a lack of horizon is common between those two things, sometimes we have false horizon capability when we're in varied terrain. It can make it really challenging for the pilot and the crew to distinguish between what's straight and level and what's canted in a turn, because you're losing that horizon that we typically reference. And sometimes that inability to reference the ground from the sky, or having that sight picture change all the time between ground and sky, can make it really easy for a pilot to start a descent or even a climbing turn or in a turn without really understanding what's going on or realizing that that's what's happening. And then lastly, being in a confined or tight area like a valley can trick your brain into proximity issues. It's harder to judge how far you are from the ground or from a rock face or from terrain, and cause your brain to make miscalculations in your relationship to the terrain when you're in a more confined area. Lastly, we'll touch on night flight. Definitely not recommended for pretty obvious reasons in mountain terrain. And that would be with the exception of highly trained and appropriately trained night vision goggle pilot and crew. Even then, comes with some inherent risks and needs to exercise some additional caution. And night flight in general, increased workload and fatigue. A lot of people on the webinar have flown at night and might understand, have some context for the additional workload and risks that night flying comes with. So when we add something like decreased terrain detail, depth perception, the lack of horizon and ground reference in mountain terrain, that is overload pretty quickly with mountains. So definitely not recommended. And we have a few different field of vision issues that can happen in the mountains. This is just one example that a snow-capped peak can look like a cloud if we don't have the appropriate visual references or night vision goggles. And that can result in really poor perception of your position within the mountain terrain. Next, we'll move on to navigation. So while flying over flat land, the direct line of sight navigation is typically appropriate. We still have to keep into account terrain that might be coming up, wires, towers, all those things. And we have to maintain situational awareness. However, line of sight navigation is made a little bit easier when we aren't dealing with terrain or mountainous environments. However, that is completely inappropriate for the most part when traveling through the mountains, and following the pink line can actually put you in a fairly dangerous situation in the mountains. So that flexibility is important. You can do a big picture planning of point A to point B, and then dive in a little deeper into the terrain where you are more specifically traveling, taking into account your weather and your performance parameters to make a more detailed route that's point A to point B. Instead of 10 miles, that might look like 1 mile or 2, having waypoints, a plan along the way, and then different escape routes. So the overall navigation planning is much tougher and more complicated in mountain terrain. Generally speaking, fly as high as necessary, however, as low as possible. And you might be thinking, why? Why as low as possible? Well, low is often a way to stay out of things like mountain wave turbulence, rotor clouds, or high winds aloft. turbulence or wind. So being close to the terrain does offer some protection sometimes. However, we also want to fly as high as necessary to keep us away and situationally aware from hitting that terrain. And then lastly, consider the impacts that the navigation has on fuel burn, weather conditions, and your communication reception when planning a route through the mountains. I have a quick example for you of a flight that is through the Brooks Range in Alaska. At the top of the screen there, you see an en route decision point for fuel. This is a very carefully planned fuel navigational plan. And so I had an en route decision point. I could turn around at that point and go back to get more fuel. So that was first checkpoint. And then you see an en route decision point for weather. And my intended route where I preferred to go is the blue line, where you can see that point A to point B navigation. And I had picked out a route more specifically through those mountains. However, at my en route decision point, I didn't have the ceilings to go over the higher mountain pass that route required. And so I deviated around, knowing that it would burn more fuel. So I was putting my fuel plan, I was tighter on fuel, but I didn't have the weather to go the other way. And the difference here is that it was about 20 miles when it was all said and done to get to my first fuel opportunity, which you see there on the left screen. And you might be thinking, well, what's 20 miles? 20 miles can actually make a big difference, especially in the mountains. And you see the math here. So I was flying an AS350 in 80 to 90 knots, ended up being about 20 minutes of extra time, which is 15 gallons in the A-Star. And that was my VFR fuel reserve requirement right there. Your company might require more. So I was dipping into my fuel requirement. I ended up having plenty. It worked out fine. It's just an example of how a difference in your route can have an impact on fuel burn, and to be sure that you have accounted for that and planned for that in your route through the mountains. And this was without anything additional like a headwind or diversion maneuvering for weather. So those en route decision points were really important for my personal planning in this situation and allowed me to get to my destination without too much anxiety. Lastly, we'll move into some backcountry preparation. So as discussed before, a lot of resources might not be available to you in the mountains. You're going to have more challenging communication. You won't have as many opportunities for fuel stops if something does go wrong or your fuel calculations don't quite turn out the way you expected. And I would recommend to never, ever pass up an opportunity to get fuel, even if it's 10 or 15 gallons. Well, that can certainly make a big impact in your ability to handle something like an unexpected headwind or a diversion and reduce your anxiety of having to constantly do that math. So never pass up a fuel stop. Communication can be limited. Satellite devices are becoming more and more common, something like a Garmin InReach device or a Spot device. Absolutely recommended. Communication is going to be your biggest go-to if you do have any sort of emergency arise. And then also consider your radio reception and navigation reception when you're planning for altitude. Of course, weather becomes an important component in that as well. So you have to plan for all of those components in your route and performance plans. And lastly, the equipment on your machine makes a difference. While we're not discussing landings, is your machine equipped with the kind of things that you might need to land in the environment where you're going? For example, snow. Do you need bear paws for that landing? Or is there installed equipment that might interfere with your ability to land if you needed to in an emergency in the environment where you're flying? Some survival gear options. Having survival gear on board or some kind of a kit is critical for operations in any remote environment, but especially in the mountains. And your specific region will dictate what you may or may not carry. If it's desert versus high alpine, cold weather, warm weather, all need to change throughout the season. But some things to consider there on that second bullet: definitely communication device, first aid kit, emergency shelter, fire starter. These are all basic survival gear and backcountry preparation pieces of equipment. And then lastly, the ELT on board. If you have an ELT, they aren't required for many helicopter operations, but they're a great idea. And there's both automatic and manually transmitting ELTs. If you do use an ELT, be sure to follow the requirements in the FARs regarding the testing and maintenance of those ELTs. And then the location of your gear. What do you need on your person? What do you need to carry with you in your pocket? Like that communication device, for example. I stick that in my pocket. If I get ejected from the aircraft in a crash, I want to have that thing in my pocket. If something happens that prevents you from getting to a cowling or getting to a storage area in your aircraft, those are all things we need to think about when we're storing our backcountry equipment and our survival gear in the aircraft. What's going to be most accessible to you if something, heaven forbid, were to happen. And then the last slide here. So how all those things come together. Mountain flying can be very fatiguing, can be very risky because of those extra mental and physical demands, not only in the planning process, but of course the actual flying and the physiological components that can creep up on us unexpectedly. And one of my favorite quotes, many of you have probably heard it, a superior pilot uses superior judgment to avoid situations which require the use of superior skill. And I cannot speak truth to that enough. It is absolutely something that I personally live by and would recommend. So that's all for the mountain flying component of the presentation. Chris, if you wouldn't mind, you can just throw my email there in the chat. And we'll switch gears here towards the wake turbulence presentation. If I don't get to answering questions specific about mountain flying right now, because I'm jumping right into wake turbulence, then I can circle back to those and type out some of those questions as well.
Absolutely. Yeah, there was one comment in the chat, but we'll keep track of that so you can get back to it as well. And I did post that link to the digital handbook that you had on mountain flying.
Oh, awesome. Thank you.
Yeah, and then another gentleman had posted one that's EASA offers as well in the chat. So make sure everyone takes a look at that. So why don't we, as you're transitioning your slide deck, why don't we put up the next polling question? And thank you for that presentation. That was wonderful. And I would add, you mentioned ELT. There's a Garmin makes that InReach device. I think they're still making it. It's a wonderful tool. You can put it in your pocket and another backup for you to be able to communicate if something happens in the mountains.
Yeah, it's a no-brainer. Those are pretty cheap subscriptions, and it's great to have. It's a no-brainer.
Yeah. All right, Ashton, if you put that next question up for us. I don't see it coming up. Ashton, are you with us? She may have stepped away. That's okay. We'll put that question up maybe in a little bit. Why don't you go ahead and start, Jessica? Thank you.
Sure, we'll get rolling. So our next section here is about helicopter wake turbulence. And this is a longer presentation that I've adapted. I know we have some time restrictions for today, so there's more to say, there's more to see. And Chris has some videos that accompany this presentation that I've removed to help us move along a little bit faster and get right to the meat and potatoes. And he's going to post those videos in the chat. So if you want to circle back and see some of the accidents that this conversation has been developed around, and you're welcome to do that on your own time. I just wanted to save us some time here and get right to the nitty-gritty of helicopter wake turbulence. So we'll move through this fairly quickly. Definitely put some questions or comments up there, and I can address those when we're all finished with the presentation. So when we think of helicopter wake turbulence, it's really two terms that we're combining into one. The first is rotor downwash, which we think of in a hover or a slow hover taxi. And then the wake vortices generated by a helicopter that's in forward flight or above effective translational lift. So more than 16 to 20 knots. There's trailing vortices that are very common or similar to the wingtip vortices of fixed wing aircraft. We combine those two terms into helicopter wake turbulence. So when you hear that, that's what we're really talking about, is the combination of rotor downwash and the trailing wingtip vortices that are generated by a helicopter in forward flight. All of this started as a result of an unfortunately fatal accident that happened a couple of years ago, where a Sikorsky S-76 helicopter crossed the path, and that's the green mark there you see on the runway, of a runway. They were sidestepping to open up the runway for this small plane to take off. And within about 30 seconds, the plane takes off, encounters the wake turbulence, flips over, and unfortunately kills the pilot. And that accident spurred a whole bunch of conversation around the hazards of helicopter wake turbulence. And where we want to start with this is looking at a variety of different helicopters and their weights the rotor disc diameters. The most common helicopters that you might see in the utility environment, flight instruction, training helicopters, are relatively light, let's say 5,000 pounds or less, with a rotor disc diameter of around 30 to 35 feet. It's the larger helicopters that could have an even bigger impact. So the S-76 there on the bottom right, at 11,700 pounds, 44-foot rotor diameter, so considerably bigger. And then something like the Black Hawk, upper right, 22,000 pounds and a 53-foot diameter. So these are tremendously big helicopters that can have a much bigger impact in their wake turbulence compared to some of the other smaller ones. Doesn't mean we get to discount the other ones by any means. However, weight and size does make a big difference here. And for that the downwash disruption, it can be dissipated or affect a distance that's 3 times the diameter of the rotor. And you're going to hear me say that throughout the presentation. So for something like the X-76, that's 144 feet. For something like the R-22, opposite end of the scale, that's 75 feet, just to give you a ballpark. For a lot of airports, this is a center line measurement from the taxiway to the center line of the runway of 135 feet. It's not that much. And the runway width is only 75 feet. So here's another example, center line runway to center line taxiway of 274 feet. And then a Class Delta airport, this is a ramp of 117 feet. So ramp, a lot of helicopters and aircraft are coming and going from that ramp, while others are taxiing along on that taxiway. 117 feet is not that far. So it gives you an idea of some of those reference points. And what we're really going for here is that rotor downwash 3 times the rotor disc diameter. And that is important because some studies have been done, and you'll see at the bottom right there highlighted 53 knots. This was, I believe, an S-76 helicopter that generated 53 knot winds within its 3 rotor disc diameter, inside of that 3 rotor disc diameter. Would you go fixed wing flying in 53 knot winds? Probably not. So why would you taxi by a helicopter that's in a hover? That's the concept, really, is how much wind can really be generated by a larger helicopter within that 3 rotor disc diameters. There's some common things, like the information that's out there. You'll see signs like this one on the left: helicopter landing area, high wind, high noise, please stay clear. Yeah, everybody knows helicopters are noisy and windy, but what does that really mean? And it can, for the example of a fuel pump, you're going to a small airport, can't tell you how many times I've heard that. Hey, just taxi on over and we'll get you some fuel. And there's a fixed wing plane sitting there innocently. So we as helicopter pilots need to be aware of how other people are unaware of putting a helicopter in proximity to a fixed wing aircraft that might cause damage, especially for a larger helicopter. Similarly, if I was a fixed wing pilot and somebody asked me to go to the pumps and I see a parked helicopter, I want to be thinking, is that helicopter about to take off? Do I need to be concerned about parking my plane here at the pumps for the next few minutes if that helicopter might be departing? And outside of aircraft, helicopter wake turbulence is strong enough to blow over people. This is an unfortunate accident that happened in March 2022, where this poor innocent woman was blown over by helicopter downwash. Again, probably a larger helicopter. What the FAA tells you about helicopter wake turbulence has a heavy focus on the hovering aspect of it. So hovering helicopter generates downwash. Yep, got it. However, there isn't very much focus on helicopter in moving forward flight. This is all it says. The energy is transformed into strong, high-speed trailing vortices, similar to wingtip vortices of fixed-wing aircraft. That's it. Doesn't really tell you what to do about it. So there's a heavy focus on the hovering aspect, but not a lot of information on what you can do in forward flight. So we're going to move in that direction. One more little pause here. So this came from the advisory circular. There's also some information from the FAA in the AIM, which gives you that 3 times the rotor disc diameter avoidance. So great, gives you some parameters to follow, but again, neglects the forward flight components. So this is right out of the AIM and the advisory circular. Those are the 2 places where the FAA provides that information. And then what's really not talked about is an investigation that happened in 1996. And some of those findings were really pretty critical. So they took a couple of aerobatic airplanes, a Decathlon and a T-34, I believe, and discovered that when those planes interacted with helicopter wake turbulence, within a half a mile, the test results resulted in loss of control in both of those airplanes. And then additional findings, both airplanes also experienced heavy shuddering or flapping of the wings when it encountered wake turbulence from the helicopter. The advancing blade of a helicopter often leaves more turbulence than the retreating blade, which is good information for us as pilots to know and understand. And then the vortex separation increases in descending flight and decreases in climbing flight, which is a little bit counterintuitive. Lastly, it might be somewhat obvious, more blades result in a larger vortex size. So something like a sky crane, for example, has 6 blades that will generate a much larger impact than a helicopter with 2 or 3 blades. So the result, what we did with those findings, is to give some more information to what to do with a helicopter in forward flight. We've got the hovering hover taxi, 3 rotor disc diameters. Okay, got it. What about in forward flight? Well, a minimum of 3 nautical miles is a good idea of distance to separate yourself between a helicopter in forward flight, and again, a larger helicopter in particular. R-22, 3 nautical miles is probably going to be more than you need, but it's still a wonderful basis and a good distance that will absolutely keep you clear. 3 rotor discs at a hover, we've been over that. And then 2 minutes of dissipation. Leave 2 minutes of dissipation behind a helicopter that has crossed your path. So 3-3-2. And this is a poster that has been developed recently, starting to be disseminated between some especially smaller airports, so that both fixed wing and helicopter pilots can raise the awareness around some of the hazards of helicopter wake turbulence. So 3-3-2. Think of a helicopter as a man-made moving microburst, whether it's in a hover taxi, or in forward flight. 3 rotor disc diameters away. Treat the helicopter in forward flight the same as heavy fixed wing aircraft, which brings us to that 3-3-2 rule. 3 nautical miles, 3 rotor diameters away, and 2 minutes of dissipation. 3-3-2. That concludes helicopter wake turbulence in a super duper nutshell. Couple of few tips that you can do and to help change the regulations and to get the word out there. An update to advisory circulars, an update to the AIM, PTS and ACS, if you happen to be a helicopter flight instructor or a DPE, helping to get this information out there in the flight instruction and training environment, as well as within our FSDO and our discussions with operators, with air traffic controllers, are often unawares. If you have to do a control tower tour, for example, making them aware of some of the hazards of wake turbulence. And then public outreach. If you have a venue, so I'm a FAST team member and active with the U.S. Helicopter Safety Team, I am happy to give this presentation in any environment, whether it be webinar or in person. So if you have a venue you'd like, myself or Ned Parks is the other helicopter wake turbulence advocate that I've been working with, we are happy to deliver this presentation to raise awareness or even arm you with the information so that you can present it to your community. And then funding for additional testing is the other big thing that we could really use so we can further our knowledge around the impacts of helicopter wake turbulence. This is my email again, and then Ned's email is on there as well. He's happy to hear from anyone. And you're welcome to, he's given me permission to put his email out. So either of us are great resources for the helicopter wake turbulence conversation, and more than happy to help. That's all I have for you.
Well, Jessica, thank you so much. There were a few comments that came in and a couple of questions. One previously, this goes back to the mountain flying. A gentleman had stated that the out of ground effect hover performance can be exceeded when hovering in ground effect in restricted areas or over sloped terrain, often by as much as out of ground effect power plus 10%. And the gentleman recommended some research that was presented by the Vertical Flight Society, which is another great organization there as well. Couple questions. I'm not sure if you see those or not, but one question came in: would you consider inadvertent IMC a hazard in mountain operations, especially in marginal weather?
Yeah, we can address that one right now. I would consider IMC a hazard in any operation and at any point with marginal weather, and especially in the mountain environment. The mountain environment just adds an additional layer of risk over whatever else you're doing. So if you're dealing with poor weather in flatland conditions, you're just adding more risk by going into mountainous terrain. So IMC is always a hazard, and you're just adding insult to injury if you're dealing with low visibility and IMC in the mountainous terrain. Highly not recommended.
Absolutely, absolutely. Another that came in, looks maybe a comment. Any information about the distance below an out of ground effect hover helicopter turbulence is dangerous? Question mark.
Yeah, that's a great question. There hasn't been a study done on the vertical impacts. The study that I mentioned, the FAA investigation, had to do with the forward flight scenario. So how helicopters and airplanes can interact with each other in a particular altitude segment, right, a block, focusing more on forward flight and not so much on vertical flight. 3 nautical miles would be a little excessive, I would say, but we don't know because studies haven't been done. I would say for out of ground effect, the ground does not have that capability to disperse your downwash. And so it's being dispersed a little more gradually as the downwash proceeds downward from your helicopter. Call it 3 rotor disc diameters vertically. I think that would be a good rule of thumb.
Hey, what's up?
In-ground effect is 1 rotor disc diameter, right? And then the second one and then the third one. So I think that 3 rotor disc diameters could potentially apply vertically, but we don't have any definitive information about that.
Yeah. Clearance is the key. So avoidance, I guess, is to say.
Avoidance,
Yeah.
that's exactly.
I did post those links to the 3 videos that you shared. So hopefully everyone had a chance to take a look at those. I did post your email address as well in the chat as well. And I don't see any other questions.
Hey, Chris.
Yes,
Bauer.
yeah,
I
go ahead.
wonder if I could just share a quick image from my screen.
Okay, go for it. I don't see anything yet. All right, here it comes.
So to the question that we had earlier, and to Jessica's point, about IMC. So this picture was taken outside of Martinsburg, or not Martinsburg, Morgantown at night. And you can see it's a clear VMC night, but there's no moon, there's no horizon. And even on a clear night, when you're flying in mountainous terrain, you might as well be IMC in terms of spatial disorientation and an inability to see terrain. So you pretty much have to really be looking at what the grid mores are and then verifying your altitude to make sure you're above them in that sector, because obviously you're not going to see it.
Yeah, definitely a dark night over the mountains in West Virginia. Thank you for sharing that, Chris.
Yeah, thanks for sharing.
That was me.
I think I remember seeing that picture one time before. All right, let's see, we got another quick comment, and then we're going to jump to our next presentation. Another consideration in mountain flying is that a higher altitude, or at a higher altitude, excuse me, your true airspeed is higher than your indicated airspeed, so your turn radius increases, and you have higher inertia to stop with less power available.
Mm-hmm. Yeah, that is true. Our altitude, your true airspeed is based on pressure. Your indicated airspeed isn't. So those two will change with increases and decreases in altitude, and should be a component in your flight planning. Yeah, that's a really good point, and can have an impact in fuel burn. Getting back to that, the planning and navigation with your fuel burn. Indicated and true airspeed, what ForeFlight spits out for you is true airspeed. So it's up to you to do that calculation based on your varied altitudes in mountainous terrain to make the conversion to indicated. And absolutely related to your question, that has a big impact. thanks for bringing that up.
Great. Well, thank you again, Jessica. Appreciate both presentations. Well done, as always. And we'll transition to our next presenter. But first, we'll do the polling question, if we could bring that up very quickly. Well, Hannah, you're getting ready. Here comes the question. Agriculture aviation pilots that hit a wire mid-flight report being previously aware of the wire. What's that percentage of the time? And we got folks already commenting. And Hannah's bringing up her presentation now. We can see that, Hannah. Thank you.
Perfect. Thanks for letting me know.
Yeah, 60%, 65% participation so far. See if we've gotten any other. 67, kind of holding steady. So why don't we go ahead and share those results? And looks like it says 85% of the time, so a high percentage.
85%. Yes, that's really interesting. And we'll get to this in a second, but I'll tell you right now, out of this data, the answer is 65%. So hi, I'm Dr. Hannah Baumgartner. I am a human factors researcher at the Civil Aerospace Medical Institute with CAMI, and I'm going to talk today about a focus group study that I did with agricultural aviation pilots or aerial application pilots. Just so that you know, this study has been completed and there is a full detailed technical report that is freely available on the Office of Aerospace Medicine website. I believe Chris has a link to that he will share. So I'm going to be giving a brief overview of the results of this study, but you can read more about it online at your own leisure. So as we are probably all aware, wire strikes are a large factor of a cause of accidents in the aerial application industry. You know, Lee's talk earlier today, as he was mentioning some of those recent fatal accidents with aerial application, he alluded to the fact that wire strikes might have been involved in those. And this has, you know, been something that we've been aware of for a long time. The NTSB wrote a report on this in 2014, listing wire strikes and in-air collisions as a really important factor to consider for safety in these operations. What's interesting to us, and you know, came at a discussion with me and some other FAA colleagues that led to this study, is that many people seem to report being aware of the obstacle or wire before they hit it. And that kind of goes against what many people off the cuff just think about these accidents, right? They think, well, if they hit it, they didn't know it was there. They didn't do enough scoping at the beginning of the run. But really, if we're seeing which we are, that people are aware of these wires before, are aware of these obstacles, then something else is going on. And that's what led to this study today. So I ran this study with 22 participants, and this took place during the National Agricultural Aviation Association's annual Ag Expo. Great shout out to Dr. Scott Brett-Hauer from the NAAA, who was super integral in helping put this together. And we did focus groups where we asked a number of questions to these individuals. I do want to note that this sample took place with both fixed wing and rotorcraft pilots. We didn't really see much difference between the two, so they're collapsed for this presentation, but it was a good representative sample of both groups. So jumping right in, because I know we're trying to keep things on schedule here. We actually asked our group a number of questions. We asked 2 more questions than this, but the main ones I'm going to talk to you about today are: to what degree were you aware of this wire or obstacle before the collision occurred? And what conditions or events contributed to the in-air collision event? Because this was really key to what we wanted to learn from this study of what factors are occurring that are leading to these accidents. We additionally asked people about steps they took for recovery and steps they could have taken to prevent the accident in the first place. Those are available in the report if you'd like to read more about it, or I can answer questions offline. But jumping right in, you know, to what degree were they aware of the obstacle before the collision occurred? Overall, we had 22 pilots who described 31 different wire strike events. You know, I wasn't necessarily expecting this going in, but going around the room at times, you know, you'd ask the pilot, what happened during the wire strike event, and they'd say, oh, which one? You know, the first time this happened. So there were some individuals with a number of these events. But overall, out of these events, 20 reported being aware of the wire and 11 reported being unaware of the wire. And this, about 65%, is pretty in line with what others have looked at. And also, as I mentioned, the IAAA has looked at this and they see pretty similar numbers, about just over the majority of people are aware of these obstacles before. So we'll keep that in mind as we are interpreting these results. Now, when I asked what conditions or events contributed to the in-air collision event, afterwards we took all this data, analyzed it quantitatively and qualitatively, and kind of sorted it into groups and themes for us to make more sense about this. And the two large themes that I'm going to talk about are situational factors and cognitive factors. And I'll break down these more as we go through them. But for situational factors, I want you to really think about things that in many cases we are aware of before we even get into the helicopter or the airplane. These are things knowing ahead of time might be risk factors before getting into the flight. And the first one of these that was mentioned by, over 55% of pilots was some sort of technically difficult operation. They're talking about this happened when I was doing a field that was all wired up, right? There were wires everywhere, wires in the middle of the field, difficult parts of the field to reach. And so the key takeaway here, right, is that we know ahead of time what fields are the risk factors, what fields, maybe we need to give a second thought about whether we're going to take or not, or plan more ahead as we're doing this. Flight stages were also a commonly mentioned thing, in particular trim passes. And for these operations, these are the final passes or the cleanup passes as the pilot makes their way around the field, cleaning up areas that they might have missed before time, particularly difficult areas. But again and again, we heard these events happen during trim passes, right? And I think something interesting here to think about trim passes and these kind of cleanup passes is that that's when pilots deviate from the routine that they've established in the rest of the field, right? And it makes sense. They have to clean up whatever it is they're trying to do perfectly. But I want to really emphasize throughout this and the takeaways from this is that there is a pressure on pilots to do these to perform very well and get the whole field, right? And sometimes we have to make sure we're balancing safety at the sake of performance. Internal risk factors were also mentioned by about 50% of the pilots. And these are things that you might expect. Fatigue, I was at the end of my day. A lot of these pilots do much of their work in a very short amount of time within the year, right? Because they are confined to the crop seasons. And so, they might be having very long days here, and fatigue is certainly a factor. One interesting thing that came up, though, is heightened emotional states. And I use the example of grief here because that was one very salient event described by a pilot. But I also want to note that it's not just negative emotional states that are risk factors for these types of operations. It's also positive risk factors too, because that's also a stressor, even if it is a positive one. It also takes us perhaps some of our concentration away. So for example, we had pilots say, I was doing this last flight of the day, my wife was about to have the baby, I had to rush home, that's when I hit the wire, right? So be careful of these types of situations too, even if you don't necessarily think of them as this negative risk factor. There were some mentions of lack of experience or lack of familiarity with that particular aircraft, right? I have a quote here that I, was flying a 402 and flying a 402 for 12 years, and then I got a 502, and it was totally different. This is referring to a different type of aircraft here. And we have to make sure we're giving ourselves time to adjust to these things, even though it feels like we know exactly what we're doing. Finally, environmental risk factors were certainly mentioned about 25% of the time. So night flying, and this did come in with some of our helicopter pilots in particular. There were you know, a long range of years and decades spanned for some of these events, for some of these pilots. So there were discussions about whether or not night vision goggles were used or not, things like that. But night flying in general definitely puts a risk factor for that. And then, as we know, poor visual conditions, weather conditions, things like that. And so again, altogether, these are situational factors that we identified through the discussion that again make sense, but are things that we should be aware of at the beginning of this day, at the beginning of this flight, and know going in, hey, these things might heighten my risk for a wire strike or some other event. Now, moving on to these cognitive factors, these are things that are a bit harder to know ahead of time. These are more like states and psychological, you know, events that occur during the flight. And so, unsurprisingly, distraction came up quite frequently. It was reported by about 60% of pilots that some form of splitting attention or distraction happened during their flight when the wire strike event occurred. And, you know, a lot of these things are very understandable distractions, right? I was distracted by other obstacles in the field. You know, I was told, make sure I don't hit the owner's garden. They'll be very mad. So I have to make sure I'm, you know, giving enough attention to avoid that. Sometimes distracted by future work. I think we can all understand the idea of getting caught up in our day-to-day, thinking about what's ahead, and bam, you lose that momentary situation awareness. Finally, some discrete event happened, like a radio call that brings a pilot out of focus. We had another pilot talk about an owl flying nearby that, you know, completely brought him out of focus, and that led to the event. There were a number of pilots, about 25%, that reported some sort of judgment call error. And, you know, these are things like just forgetting the wire was there. I knew it was there, I just totally forgot. Or I knew it was there, but I really misjudged my proximity to the wire. I got too close. I thought I could make it and I couldn't, right? Performance pressures were often reported about 25% of the time. And this is one thing that I want to pay special attention to, because I think it's one thing that's, you know, somewhat in our control that we can think about as we're doing our day-to-day jobs. And, you know, I made this comment in the past, but what I learned throughout these focus group studies are that aerial application pilots, they're really perfectionists, right? Because they want to get that field completely perfect. They want to do the absolute best job that they can. You know, they miss that little spot in the corner. Oh, let me go around and get it again, because they take pride in their work. And that's absolutely understandable. But it's also important to realize that it is these trim passes, these cleanup passes, this deviation from the norm in our flight that we're putting ourselves more at risk for this wire strike event. And so there is a balance there, as I mentioned earlier, of making sure you're doing the best job possible, but not at the expense of your own safety, right? Other internal pressures were noted, such as the internal pressure to hurry, right? I have a lot of flights in this day, I have to keep going. Or, you know, there's someone coming down the road ahead, I want to make sure and I finish this up so I'm not getting in the way of them and having to divert my plan so that I'm not spraying that person, things like that. Again, these were reported in about 25% of the time. And finally, the last cognitive factor that I wanted to talk about, this wasn't reported by too many people, but it was really interesting to me because it was a phrasing that came up specifically from different pilots on their own, and it referred to breaking their own rules. So these pilots noted that when they had their wire strike event, it was on flights that they did something different from their norm. And, you know, they already knew they were doing something different from their norm because they were breaking their own personal rule. So, you know, here's a quote. It was an area that I could only get 2 passes into the side of a busy road, and I broke my rules. Normally, first pass is a power and height to make sure I clear everything. And so I think this is a really powerful statement here that shows, you know, individuals often know when they're doing risky or riskier behaviors, right? Because you have your own set of guidelines that you lead yourself through in your day-to-day work, and it's important to listen to those and, you know, trust your intuition to some degree. And so again, just in general, these were the multitude of factors that we noted. There's a big range here, but there's not a lot of research into these events, and it's starting to break the surface of what kinds of things lead to these events. And as I mentioned, we have the situational factors that can kind of be thought of almost as pre-flight risk factors, right? What fields are technically difficult when you scope them. They're wired up. If you're jumping a wire, things like that, that's where some of the risk might be. Trim passes are an exceptionally high risk phase in comparison to other passes. In-flight risk factors, such as those cognitive factors, are a bit trickier though, because you really have to constantly reevaluate yourself for those in the moment. Make sure you're not getting distracted, staying in that pass, every pass. And that's very difficult to do, but that is the nature of the game. As I mentioned in our polling and before, most pilots are already aware of the wire before collision, meaning that it's not necessarily a scoping problem for most of this. It's not hidden wires, it's not tricky wires like that. It's some other factor. And throughout the rest of the report, which I didn't mention here, but there are a number of recovery steps mentioned by pilots and potential prevention steps. But finally, I do want to note that, of course, the biggest limitation in this whole study is that we're talking to people who survived, right? And so there is something certainly to be learned from that in comparison to the fatal wire strike events. And I think a lot of these things, the difference between a guy wire versus like a power wire, things like that might get into play here. But I did just want to note it. Again, I'm happy to answer any questions that you may have, or feel free to email me, and there is a report that Chris can share with the group. So thank you.
Awesome, Hannah. Thank you so much. I did post a link to the full report in the chat, so hopefully folks can reference that and learn more. Notable in your findings, certainly decision making, as I talked about earlier. As with anything in this industry is critical, but I also like how you referenced the positive pressures that influence the choices that were being made, and certainly we don't always want to focus on the negative. There are positive influences. The get-home-itis in some cases.
Yeah, definitely.
In the aeromedical industry suffers from as well. So thank you for that review, and appreciate you compressing all that into information to provide to everybody. There was one question, and I think you answered it, but just to verify, were the pilots in the focus group helicopter pilots or a mixture?
It was a mixture of both.
Great. And I don't think there were any other comments or questions, so I appreciate that. I did post a link to, and Scott you referenced Scott, he is on the webinar as a participant, and I did go ahead and post a link to the National Agricultural Aviation Association safety resources that they have, and they are having a conference coming up in December in Palm Springs, and I know Scott's got some safety related training for there as well. I did post another link. HAI just released a spotlight on safety related to low altitude obstruction, specifically wires. So hopefully folks, you clicked on that link. It does talk a lot about the issues around the wires and so forth, and some other resources that might be available. So thanks again, Hannah. Appreciate that.
Thanks, Chris.
Yeah. All righty. Well, we are almost at the bottom of the hour. And so just appreciate, we've got no other presentations. I do appreciate everybody's participation. I've got a slide up on the screen here. We're shooting to do our next webinar in January, hopefully. That may shift a little bit, but nonetheless, if you're going to be at Heli Expo, it's going to be the week of 26th February in Anaheim. We will have an in-person meeting there on Wednesday, the 28th at 8:30 a.m. Pacific time. And then I've got a little QR code there for the various safety resources during Heli Expo. For those that have attended that in the past, there is a lot going on during that week from a safety perspective. So I hope you all have a chance to attend that and then participate in those various seminars, Rotor Safety Challenge, Safety Symposium, Safety Directors Forum, Safety Town Hall, and USHST's own meeting as well. I don't know, Chris or Robert, if you had any closing comments, and my co-chair Jeff Zimmer's on the line as well. So he's with the FAA, he's a government co-chair, and I didn't know if Jeff, you had any comments.
No, it was a great presentation by all. Thanks very much.
Great. Let's see, there was one question: how do we get credit for IA renewal? It should, if you're registered in the FAA database, the FAA safety team, it should happen automatically. We'll provide all the attendees' email addresses. You just may want to make sure that email address is correct to get the AMT as well as the wings credit. And Chris, did you have any closing comments?
Great webinar, Chris. Jessica, Hannah, you guys are amazing. Thank you so much for not just your time, but the quality of your presentation. I'd love to talk with you offline about our new newsletter we're putting together and see if I can talk you into being a contributor. Chris, thanks for just an amazing job.
Well, no, thanks to our presenters and all the behind the scenes support from HAI and the FAA. We couldn't do it without the whole team involved. So thanks again for everybody's participation, and we look forward to doing this again in January. Bye, everybody.